Thanks for joining us today. My name is Billy, along with my co-author, Alex.
Hello, everyone. Thanks for the introduction, Billy.
Todd and Jesse. So what we're going to talk about today is the book we've been working on called GitOps and Kubernetes, and we'll give you a high-level overview. And also through a set of demo, hopefully you learn the key concepts. So first I'll talk about is the evolution to GitOps, how we get there. Then Todd will cover Kubernetes, why that's perfectly complementing GitOps. Then Jesse will give you a basic GitOps operator demo, see how easy you can set up a GitOps operator. And then Alex will go into several production-ready tools that is on the market right now, and also give you a demo of one of them is called Argo CD. So how did we get here? So if I wind the clock back about 5-10 years, depends on where your company's at. The way we used to deploy software is, of course, as a developer, we write the code, we test it out, and then we pass over our quality assurance team to do further testing. And then when everything is said and done, then I finally will ask our operation team to deploy the software. So if you imagine what we used to do is from the time we actually write the code to actually got deployed, sometime it might take weeks. And then when you see actual problem at that point, you can try to remember what you actually did back then, right? Because these codes are written weeks ago. So it creates two sets of problems. One is it takes a long time to get features out. Plus also when, when there's a problem happens, you have to context switch to figure out, what happened back, weeks ago, or what did you do? So now, from that point on, we evolved to something called DevOps. I guess a little lag on the screen, but okay, here we go. So really the difference now is with the recognition saying having all these jobs separated, we're gonna ask team to basically do, basically doing all the heads at once, but of course with a lot of automation to make it simple. So in this case, basically every developer will not just code the feature, they will do full testing, and then they're empowered to deploy anytime. And also doing this, support if there's a problem. So that, what it really accomplished is taking, something that takes weeks from coding, from development to into deployment. Now, as soon as it's done, tested, it's out in the customer hand. So feature gets out a lot faster, and also for engineer, there's less context switch. So company like Netflix pioneered this type of process, and also they built tooling around it, such as something called Spinnaker, right, which is a great UI tool, lets you, deploy software through just a couple button click, which is great. But now, there's one minor problem is, it's a lot of times very difficult to try to see, what actually changed or what you deploy is different from before, and also infrastructure changes, because you don't get from this UI tool, a lot of them don't have the, versioning, and also it lets you kind of, see what's before and after. Plus, they don't give you any kind of process to track who did what, in case that's important if you're in a compliant business. So that's how we evolve into something called GitOps, which is a term coined by Webhook originally. And it's been getting pretty popular in the last several years, especially in the Kubernetes community. The key concept here is basically, instead of using some kind of UI tool to deploy, now all your changes actually also become a Git commit. So you describe your infrastructures through like a manifest in the declarative manner, which we'll talk about in a minute. And you check into Git, and then what happens, your Git operator will automatically take that and deploy. So now you have full history of what got changed, plus you can diff between the commit to see what was actually changed. So that's really what the power of GitOps is, but it's also essentially an evolution from DevOps. So the benefit for both developer and operation. Of course, the first benefit for a developer is now even infrastructure described code. It's not like some UI or some database. You don't even see exactly what's going on, but now you can describe everything as code. And it still empower the same thing, self-service, but on top of that, it also enable you to do pull requests and code review, just like any other code, to catching error early. Plus, in case of compliance type application, you have a approval process involved. For your operational benefit, it gives you full visibility and observability into what was changed. And I also talk about the auditability and compliance. On top of that is if you ever have to rebuild your environment, everything is fully checked into Git, so you can just get the latest version reapplied to a new environment for disaster recovery. And for rollback, it's even simpler. Basically, rollback is just the same as you revert to a previous commit. You're done. So next, Todd's going to give you a quick overview of Kubernetes, why this is complementary to GitOps.
Schedules those containers on certain nodes, and manages that process. Containers really give you a standard way to package up your application code, and so that the configuration and the dependencies are all within that single resource, that single container. That helps for repeatability and reduces variation when you deploy from one environment to the next. If you're deploying the same container definition, then it should be the same in each of your different environments. Kubernetes also has this concept of primary resource types, like a pod, that can then be also leveraged by higher level resource types like replica sets and deployments. So it's and that leads to the fact that Kubernetes can be easily extendable. So you can extend, for example, if you have a primitive like a pod and you want to implement the functionality of a replica set, you can implement that by leveraging the functionality of the underlying pod. Just like if I want to create a new type of object on top of a deployment, I could also do that as well. Kubernetes also allows you to add additional operators that are looking at different types of resources in your Kubernetes cluster that perform additional actions. And we'll be talking about operators a little bit later in the stream. Kubernetes also offers both imperative and declarative interfaces, and we'll come back to that. That's one of the key things that makes Kubernetes a good fit with GitOps. And we'll come back to that in a few slides. So here's just a very simple diagram of a typical namespace within a Kubernetes cluster. You'll have, you might deploy a replica set that says, okay, I want to deploy 2 pods to run my application. That pod might define several different containers. Each container does a particular operation. You might have one container that initializes the environment and gets things ready, and then you have another container that's running your Nginx or your, whatever your application is. And those pods can mount volumes, either ephemeral volumes that are temporary storage or persistent volumes that are coming, that are stored on external storage. Then those pods can be exposed to the outside world using a service, and then they can accept traffic. So when we start talking about a environment, say an application environment, you really want to define all these different components, and these are all defined. These are all software defined components within Kubernetes. You can create services, replica sets, pods, containers, volumes, all by defining them in the configuration of the Kubernetes cluster itself. But how do you do that? So, and how does that play in with GitOps? Well, as I mentioned earlier, Kubernetes offers both imperative versus declarative interfaces. And we'll get into more specifics on Kubernetes, but to illustrate the difference, on the left side you see the imperative remote control, and that means I want to I want to increment the volume by 1. I want to decrement the volume by 1, such like that. So if I'm on channel 3 and I want to go to channel 4, I need to press the up channel button. If I'm on channel 3 and I want to go to channel 1, I need to press the decrement button twice. So using that imperative remote assumes that I have some prior knowledge of the current state of the system, and I have to sort of maintain and know what that state is before I can operate it. Whereas if you go with the declarative example, the declarative remote, I just press a button. I just say, okay, I want channel 3, I press channel 3. I press the button for 3, and it, the TV tunes directly to channel 3. If I want to turn the TV off, I press the off button. What if the TV was already off? If in the imperative example, pressing the power button might turn it on when I thought maybe I wanted to turn it off. So anyway, that's kind of an analogy for how imperative versus declarative works in Kubernetes. The reason this is important is the imperative, the declarative nature of Kubernetes makes it much easier to implement GitOps. I mean, that's really a key enabler for GitOps. So here I'm going to do a quick demo to illustrate imperative versus declarative in Kubernetes. If you wanted to follow along, you could go ahead and fork this repo and just make sure you're running some kind of desktop Kubernetes environment where you can run Kubernetes commands. Either I'm going to be using Minikube, and you can follow along. So let me switch my screen now. I'm going to stop and share my IDE. So in this case, I just spun up a fresh new Minikube cluster running on my workstation. Look, there's no pods running. And I have this script, and this is under that, if you're looking at the repo, this is under chapter 2 of the resources repo. I have the script, and you might look at the script and say, okay, great, I'm doing DevOps, right? I'm writing code to define my environment. So I have these different kubectl commands to create a deployment, scale that deployment to 3 replicas, annotate that deployment with some annotations, and and I'm good to go. So yeah, let me go ahead and run that. So I'm going to run this imperative script, and now I'll watch. And we should see these containers creating. So at least I got the output that the deployment was created, the deployment was scaled, and the deployment was annotated. So far everything looks good. And now I have 3 running pods. I'm good to go. My deployment was successful. So then if I describe the Engine X imperative deployment, you'll see that it's all running, and it's got the annotations. It has the environment prod and organization sales. Everything looks good. So let's say I check this code in. I say, okay, this is my code for deploying, creating my deployment for my Engine X application. And now someone says, well, you really, sales isn't really the right thing. You should really change that to marketing, because it's really marketing's Engine X. It's not really sales per se. So I go here and I say, okay, let me change this to marketing. So I change it to marketing. I save the file and I say, okay, I'll just run it again. I'll just run this script again. Oh, wow. Okay, I got some errors here. So number 1, the deployment already exists, so I can't do another create on it. The scaling is fine. It scaled to 3 replicas, and it just scaled it again to 3 replicas. That's fine. But then it's complaining that the annotation already exists, already has a certain value. Okay, well, I could add the override command, and I could do some other, I could do an if check, like if the deployment exists, then do a create, don't do a create, do an update, and if the deployment doesn't exist, do a create. And so I can make this script more and more complicated. But why would I want to do that when I don't have to, right? So that's where the declarative comes in. So instead of writing a script like this to do everything very programmatically, step by step, Kubernetes allows you to define your environment, your desired environment, and make changes and define it that way. So here's an example of the exact same result. The same end result is exactly the same. I have these two annotations. I have 3 replicas. But what I'm doing is I'm saying this is what the deployment should look like. This is, I'm declaring the desired state, right? So then if I do a kubectl apply and do the declarative deployment, it creates the deployment and everything's set the way I want. I can do the watch again, and I can see my containers getting created. And then if I do the describe and instead look at the declarative deployment, I see it's pretty much identical. It has the same annotations, has the same everything. Now, if someone says, oh, you should change that organization instead of sales, it should be marketing, I can go here, I can simply just say marketing and save that. And then I can apply, I'm basically applying the same manifest again from the file. And I apply it and it says, okay, it's configured. And if I look at the deployment again, I'll see that the organization was changed to marketing. So one of the key enablers of GitOps is that you can have this declarative specification of your application, the infrastructure that your application depends on, and you can make changes to that simply by changing this declarative file and then reapplying it to your Kubernetes cluster. And that's what we'll talk about in the sections. So let me switch back now to the slides. And I have a few placeholders we can skip over. So again, the imperative deployment, you have the script that you can run, but instead of having a script to run, you have a declarative deployment that has the the end result, the desired state of your deployment. All right, pass it on to you, Jesse.
Yeah, let me start sharing my screen.
You want to talk first about this slide?
Oh, sure. Okay, yeah, so how GitOps is implemented in practice is you are running a operator or controller that is continuously in this reconciliation loop. It's forever in this constant circle of basically checking the contents of a Git repo, searching that repo for basically walking that directory for any manifests that need to be applied into the cluster, and then essentially just applying those manifests. So this, in summary, like all GitOps operators are doing this reconciliation loop, and the different versions of it might add various features like a UI on top of that, but they all kind of follow this basic principle. So I often describe GitOps as kubectl on a cron job, and that's actually what the next demo will be about. So if you can switch to my screen, can you guys see this yet?
Yep, I see it.
Okay, great. Okay, so if you want to follow along, you can go to the GitOps book resources, and we're in chapter 2. And the examples you want to see is the GitOps resources and the GitOps cron job. So I'll open that in my IDE. So the first thing we'll do is we'll actually install our quote unquote GitOps operator into the cluster, which is for this demonstration will be a cron job. But the first thing we need to do is we need to give it privileges. So our demo will run in the GitOps namespace. And it needs, since our operator needs to deploy manifests, we need to give it cluster admin privileges. So this service account and this cluster role binding will grant our job the ability to deploy. So let's go ahead and deploy that. Okay, and so then now that we have privileges, let's actually install the quote unquote operator. So if you look at this cron job, I have a cron job running every minute. And really all this cron job is doing is cloning a Git repository, walking that Git repository for YAML files. And then for every YAML file that it comes across, it's going to run kubectl apply against that that file. So we'll go ahead and apply that. And while I'm doing that on the right side, let's also watch for pods. Okay. Okay, so it'll take about a minute, but while we're doing that, I can bring up the what is it actually going to deploy? So let me okay, so the repo that you saw is just this simple deploy repo, and it has a single service and single deployment. And so what you just saw happen on the right side was after 1 minute, my cron job fired. So this GitOps-cron is the actual Kubernetes job that fired. Once that ran, you can see that this pod sample app got created and was running. So now if I look at what's in my namespace, we see this sample app deployment that was created, and that was this deployment that we had defined in my my Git repository. Okay, so what happened here was that I wasn't the one actually doing the apply. It was actually the GitOps operator that was doing that. So by doing so, since like the Git is the source of truth of what you're trying to deploy, your deployment processes can all center around using something like GitHub or GitLab or Bitbucket to perform deployment. So you no longer need to give people, your developers, direct access to your Kubernetes cluster. And then with GitOps, the changes can go through formal approval processes like pull requests. So continuing with this example, let's actually do a GitOps change. This is a fork of the sample app repo, and my cron job is monitoring this repo. But let's say I want to bump up the replicas to 3, and also I want to bump up the version to the second one. So all I have to do is to make this commit. then eventually the GitOps operator, and let me start that on watch. Eventually, the operator within a minute or so will pick up my changes and then kubectl to apply those changes. And one thing I forgot to mention was that the nature of kubectl to apply, it's safe to actually apply that like early and often, because the way kubectl to apply works is it only applies the differences that you made in your manifest. So if there wasn't any differences at all, the kubectl to apply is basically a no-op. It will have you'll even see a message saying there is no changes. Okay, great. So we saw that some activity going on in my namespace. Basically, you can see that my another GitOps cron job fired, and as a result of that, the sample app got changed. And if we look at my namespace again, we see that same sample app, it now has 3 replicas. And then if we look at the contents, we see that the image has been bumped to 2. So that's a very, what we call the poor man's GitOps. It's useful for explaining, the basic concept of GitOps. But of course, no one is going to run their deployments in this way, and so that's where we get to the more advanced GitOps operators. So there are, in our book, we cover 3 tools: Jenkins X, Flux, and Argo CD. There isn't much time to go over all 3. Each of these has their own kind of spin on their approach to GitOps. But since Alex and I are maintainers of the Argo CD project, we'll go into some details about how Argo CD works. So Alex, do you want to take over?
Yep. Hopefully you can see me, guys. Okay, so as Jesse mentioned, I'm going to talk more about Argo CD. So I will cover what is so special about Argo CD, and then I will talk about Argo CD architecture, and then there will be a demo which will demonstrate what you can do using Argo CD. Before jumping too much into details, I wanted to maybe answer a question like, why do we have so many tools? And that's important to answer the question, why Argo CD even exists. So as you could see from Jesse's demo, that GitOps actually is not rocket science. It's literally just git clone, kubectl diff, kubectl apply, and but still we have several GitOps tools. And so I think the answer is that happened because every tool, yes, it uses GitOps function as a core feature, but it's a little bit wider in scope. So for example, Jenkins X maybe has the widest scope, and Jenkins X actually has opinionated workflow for the whole application lifecycle. So it can do a lot, including GitOps. And Flux is a maybe completely different example. It's really focused on GitOps, but it still has opinion. So Flux really kind of a great fit for power Kubernetes users, for engineers who know Kubernetes very well and they prefer to use CLI maybe to manage Flux as well as Kubernetes. And finally, Argo CD. To start talking about Argo CD, I want to start sharing my screen and maybe take over. Okay, thank you. All right, so I can keep using these slides. So Argo CD, basically, like, why does it exist and how is it different from, let's say, Flux and Jenkins X? And in one sentence, Argo CD is a GitOps operator for enterprise. And what does it mean exactly? So basically, we believe pretty much every enterprise that tries to do GitOps needs following three main features. So first one is multi-cluster management. And the reason is that practically even a small team that manages one microservice have to deploy into multiple clusters. This is just the reality. So Kubernetes cannot yet, at least, manage your whole company infrastructure. You are going to, for performance reasons, for security reasons, you are going to have many clusters. And typically we see every team starts from at least two. So your pre-prod QA environments goes into pre-production or staging cluster. Your production goes into production cluster. As soon as you need to, add a second region in a cloud, you're going to introduce one more cluster. So it's already three, and the number keep growing. And that became extremely important for our users to be able to manage multiple clusters. The next feature is multi-tenancy. So what that means is basically multiple teams can use a single Argo CD installation. And that is powerful because at this point you have a single control plane for your virtually whole infrastructure in your organization. And Argo CD enable multi-tenancy by features like SSO integration. So you can use I don't know, for example, Okta or RBAC using DEX or LDAP, any SSO provider to log in into Argo CD. Plus, Argo provides you a flexible RBAC system, which enables you, it gives you a flexible way to control what your users can do and cannot do. And finally, Argo CD has UI. So, and UI, it's on top of everything else. So because Argo CD has access to information about your whole infrastructure, plus it also knows live state as well as expected state, Argo CD is actually a super powerful Kubernetes dashboard, and it enables day two operations. Day two means after you already have everything up and running, you still need to maintain things. And the great example of power of Argo CD is that your developer, the end user of GitOps tool of Argo CD, can simply send a link to a support engineer and ask a question, hey, why it doesn't work? And that link has all the information which support engineer needs to know to answer the question. Yeah, so I think these three features actually make Argo CD different and make it ready for enterprise scale. And next, thank you. Great. So that was a little bit long introduction, but it actually helped to answer the question why Argo CD architecture is not just a single pod which runs inside of a cluster. And the reason is it's trying to be able to useful to thousands of developers at the same time. And as soon as you want to do that, that means you are going to meet some scalability issues. So basically, you need to clone a lot of repositories, and you need to get this live state of multiple clusters. And this is why we have three layers in the Argo CD architecture. Let's talk from the right one, which you see on the screen, which is Argo CD repo server. So as I mentioned, GitOps is just git clone kubectl diff kubectl apply. So Argo CD repo server is git clone. It's a little bit more difficult in practice. So Argo CD repo server not just cloning the repositories, but it is also provides integration with config management tools such as Helm and Customize. And repo server is a separate component. It's because you might want to scale it differently. So if you have thousands of repositories, you maybe need more than one instance of Argo CD repo server to handle the load. Okay, the next component is Argo CD application controller. And Argo CD application controller is responsible for kubectl diff, kubectl apply. Again, it is a little bit more complicated. So as you could see from Jesse's demo, that we periodically need to check the difference between live state and the desired state. So application controller does it all the time, literally thousands of times per minute. And that enables us to give to, report to the user really close to real-time state, and controller can detect changes very quickly, literally within several seconds, and quickly apply changes if it's configured to apply changes when diff is detected. And finally, we have Argo CD API server. So API server is the entry point to Argo CD. Basically, it powers the UI and the CLI, and it presents to the end user results of work of application controller. So user can see if there was any difference detected. User could find what exactly is different, and I'm going to show you it very shortly in the demo. And finally, a few words about persistent. So persistence. Basically, all the components are stateless, and that means you can delete all the pods of Argo CD, and then as soon as new pods are recreated, everything is going to work in the same way. You won't lose any data. We use Redis, and Redis is stateful, but even if you delete the Redis volumes, application controller will immediately recreate the same data. So basically, Redis is just a throwaway cache. And finally, we do have some settings which we store in Kubernetes, typically in a control plane cluster. And it is not okay to lose the control plane cluster, but you can actually also store all the settings of Argo CD in your Git repository. So basically, you can use Argo CD to manage Argo CD using GitOps methodology, and that pretty much covers the problem. Okay, finally, I think we are ready to do the demo. I need to start sharing my screen. Can I get my screen, please? Thank you. Okay, we are at this slide. And yeah, so basically now we can switch to the terminal. Okay, we need to talk about some abstractions which Argo CD introduce. And one of the most important ones is Argo CD application. And instead of explaining, what exactly application, I just want to show you a CLI command which can create an application. And then from just analyzing the parameters of that CLI command, we can understand what application is. And I moved too quickly. Yeah, I was supposed to mention that, yes, before the demo, I did create an Argo CD, so I already have it up and running. And I have a sample GitOps sample repository with GitOps manifests, which is actually the same repository which JC used for his demonstration. So if you want to, do the same thing, please use Argo CD documentation basically to create an Argo CD and use the repository which is available in the slides. Okay, let's get back to the CLI. So this CLI command creates Argo CD application, and the first parameter is the name. And name is just a unique identifier of an application. And in my case, I'm just going to use sample app as a simple name. And next, two parameters kind of linked together. It just explains Argo CD which resources we want to use as an expected state for that application. So in this case, I'm saying to Argo CD, hey, go ahead and find this Git repository and then use the root path from that repository, and it will have everything you need to deploy. So I think it's pretty simple. And the next is where I want to deploy. So I'm just saying here that, hey, Argo CD, please, all these resources have to be deployed into the same cluster where Argo CD is running, into the default namespace. Great. So I think hopefully that explains what application is. And let's go ahead and create it. So as soon as I run that command, Argo CD went to go ahead and it cloned the repository, and basically application was created. And you do not have to use CLI all the time. As I mentioned, we have user interface, and I want to go ahead and switch to that interface. Cool. So this is how Argo CD user interface looks like. We are landed on application list page, which is that powerful dashboard I was talking about. So basically, it's supposed to show all the applications which your Argo CD manages. And in practice, you might have even hundreds or thousands of them. I have one. So if you have a lot of them, you can use filters and you can use search. You can type the name of your application. As soon as you found what you're looking for, you can click on that UI element, which represents an application. And then here you will be redirected to application details page, which is, I guess, the most powerful page of Argo CD user interface. Okay, so what do we have here? Let's start from application resources tree, which is this area in the center of a screen. So it is showing to us that all the resources which are supposed to be included into your application. As you might remember, actually, let me go ahead and open the repository. So this is what we're trying to deploy. So because we have deployment and the service in the repository, we expect to get the service and deployment in the application. And so this element at the center is the application itself, and two blocks on the right side are service and deployment. So, and let's go ahead and click on deployment. So here you can see a status, and these several tabs. One is live state, there is desired state, and the diff. So live state is empty. The desired is what we stored in the repository, and the diff is what we have and what we're supposed to have. So we're supposed to have a deployment, and we have nothing. And this is expected because we didn't tell Argo CD to do anything. It just keep track of what you have in Git and the cluster. And next, we're supposed to make a decision, what we want to do with it. And we have several options. One option, maybe simplest one, you can just configure Argo CD to just automatically deploy expected state into the cluster as soon as it notices a difference. It is not really convenient to do a demonstration. That's why I choose to control it manually. And if you want to control it manually, which is often case in production, you might want to either use your CI pipeline to drive the deployment, or like me, you can just click a sync button. Basically, you can use user interface. And let's go ahead and sync the detected changes. So I'm going to click on sync button, and it's just going to show me kind of a confirmation screen. So the summary says you're going to create two objects. Let's click sync, and come on. Okay, things start happening. As you could see, now this little mark is now green, which means it is synced, and even more data is been shown to us. So in addition to deployment, we now have more blocks here. And as you maybe remember from Todd's explanation about Kubernetes, so some Kubernetes resources create child resources, and even more, these child resources can create even more like children. Basically, we have some hierarchical relationship between resources, and Argo CD tries to visualize it. So on my screen, you can see deployment, which has replica set, which has pod, and you can get information from about the pod itself. So what the screen does, it helps the end user, your developers, to understand what is happening in the application. So developer might go ahead and click on the pod, and in the pod, on this panel, user could see the live manifest of that pod, then events. So basically, we can see when the pod was created, then the image was pulled for that pod, and on the summary view as well, you could see quickly image that runs that is used in that pod, and you can even see containers and logs. But this application has no logs, so basically that's why it is empty. Cool. So this is all great, and I think the most important demonstration is how to make a change and how to actually execute GitOps. So it's really easy. You can just go ahead and make a change in the deployment. Great. So I'm using just the GitHub interface to make a change, and I'm going to simply bump the image version from 0.1 to 0.2. There is save button, and I'm committing directly to master, which is fine for the demo. So let's move back to the interface. So nothing changed yet, and the reason is, so Argo CD detects changes in a Git every 3 minutes. Basically, it keeps tracking the Git, keep pulling from the Git every 3 minutes. You can configure a webhook. So webhook will tell Argo CD that it should change right away. It should check the Git right away, or you can just click a refresh button here, or we can wait for 2 minutes, but we obviously don't want to do it. So I clicked the refresh button, and you could see that status has changed immediately. So basically now Argo CD knows that something is not right, and using Argo CD interface, you can detect what exactly is not as expected. So as you can imagine, deployment is running now not what we expect from it in the Git. You can click on deployment, and now the div tab is a little bit more useful. So basically, it is showing to us explicitly that we're supposed to run version 0.2, but we actually run 0.1. And next, we can go ahead and sync again. So I'm clicking the sync button, trigger the synchronization, and now we can use Argo CD user interface to see the progression of deployment. And I think this is a great demonstration of this, day 2 operation tasks which your user might have to perform. So what happened is a second replica set was created, and immediately a new pod of new replica set was provisioned. The old pod is still running, or it just disappeared. So Kubernetes did its work. Basically, it validated that new pod is healthy, and then it went ahead and killed the previous pod. Cool. I hope that explains what Argo CD provides you. And Argo CD has actually a tons of other features, and it's not going to fit into 1 hour time slot. Yeah, and hopefully you enjoyed the demonstration. I'm going to stop sharing, and I think we still have 10 minutes for questions.
Yeah, obviously, while we're waiting for questions, obviously we have this book that goes into a lot more detail. It's available through the Meet program currently, and we're working hard to do the final finishing touches on it. Right now, all the chapters are complete and live in the Meet, so you have full access in the Meet to all the content. And we're, like I said, we're looking to wrap up the final edits for the printed book shortly.
All right, if there's no other question, thanks for your time. And I think we could be rich. Just let us know if you have any questions and check out the book.
Great. Thanks.
Thank you.
Thanks.